Good day, stat students. So today we're going to talk about section 2.4, and it's large enough that we got to separate this into part 1 and part 2. So today we'll talk about part 1, and we're talking about measures of variability, the spread of the data set. And so what do we talk about when we're talking about spread of the data? Okay, what do we talk about measures of variability? Well, let me give you two data sets and I'll show you. So here's two data sets. They're both bell-shaped, all right? But this one over here on the left, let me get my pen out. The one over here on the left appears to be a lot more spread out. Remember, these are the values of the variable down here. So this one tends to be more spread out than, say, this one. Okay. So this one, you can get values, it seems like all the way out to maybe 40 to 160, and over here, it's very much limited to about 90 to about 110. Okay. And so what we're seeing here is that for this data set over here, all right, you're going to get larger measures of variability. Why? It's more spread out. Okay. And over here with this data set, you're going to get smaller measures of variability. It's a lot more condensed. Okay. So there's a couple of different measures of variability that we're going to talk about in this class. There's more than this, but here are the ones that we're going to talk about in this class. We have the range, we have the standard deviation, and then we have the interquartile range, the IQR. But we're not going to talk about that until section 2.5, and so you'll see that more in 2.5. Today we're going to talk about range and standard deviation. So we have two data sets, data set A and data set B. All right, and just looking at this, hopefully your intuition tells you, well, data set A is more spread out than data set B. Okay, so it doesn't matter if this one has 5 observations, this one has 6. That doesn't matter. What matters is that how spread out is the data with regards to measures of variability. So this one appears to be more spread out A versus data set B. All right. So we'll say that both of these are time to campus in its terms of minutes, all right? And so data set A, we'll say, are full-time college students, okay? And so you have students that live on campus, and so, you know, if I asked 5 people in class, maybe one person would live on campus, and so they didn't have any time to get to campus today. Whereas you might have people driving, you know, 30, 40 minutes away. That's not that unreasonable, all right? Whereas high school students, they may have to go, generally speaking, they have to go back between high school and college, and so they're not going to be that far away from campus, okay? And so that's what data set B represents. All right, so here's the data set again. Let's take a look at the range. So the range is just one value. It's a calculation. And so sometimes I even do this because there's some value in it. That I'll say the minimum is 0 and the maximum is 40, and so sometimes people say that's the range, 0 to 40, or for data set B, 6 to 14. That's not the case here in statistics. It's just one value. It's a calculation. What's that calculation? The range is just simply the maximum minus the minimum. Max minus the min. And so the range for data set A would be 40. Why? Because the maximum is 40. The minimum is 0. You do that calculation, you get 40. Now, I don't know why that's off-centered, but range for data set B, maximum is 14, minimum is 6. You do that subtraction, you get 8. So that's telling us how far away the maximum and the minimum values are, okay? And certainly that's a measure of variability, okay? How spread out is the data, all right? Do you see any problems, any potential problems in using, so since the range for data set A is greater than B, this is an indication that A is more spread out than B. That's sort of an obvious statement. I don't think I have to necessarily state that anymore, is that if you have two data sets and for measures of variability, if one is higher than the other one, then that one with the higher one is more spread out. Okay. All right. Now, what are the potential problems using the range as the only measure of variability? Can you think of any? There's two I can think of off the top of my head. One is that it only uses 2 numbers from the entire data set. It only uses what? It only uses the minimum, maximum, minimum, maximum. It ignores all the other numbers in between. Okay. we probably want a measurement that uses all the values of the data set. Okay. And then 2, it's greatly influenced by outliers. Why? Because the outliers are going to be located where? Either the minimum and or the maximum. And so outliers greatly affect the range. And so we have to have something that's going to look at all the values of your data set, and it's not so influenced by outliers. Which takes us to the standard deviation. So the standard deviation, I would call this the king of variability. Why? Because if other, not alone statistics, but other disciplines, when they talk about variability in the data, they're probably talking about standard deviation. And so this is universally known. It is more resistant to outliers in the range, not completely resistant, but it's a little bit more resistant to outliers in the range. 3, it uses all the values of the data set to calculate it. And so what exactly is its definition? Its definition is this. It's roughly the average distance all the observations are from the mean. And so if you went ahead and had a data set and you calculated standard deviation to be 7, what that's telling you is that the observations are roughly 7 units on average from the mean. Okay. So now, before we get into the calculation for the standard deviation, I want to bring something up, and that's the next point on the slide. Here's a question for you. What's the difference between the following division signs? I know it sounds a little weird to ask this question, okay, maybe even a little elementary, but it brings up a point that, just in case if you haven't worked with formulas too often, okay. So here is 8 minus 4 divided by 2 minus 1 versus 8 minus 4 divided by 2 minus 1. What's the difference between these two? Well, this one over here on the left, remember we always have to follow the order of operations, right? And so remember your order of operations that you have to do division before you do subtraction. So you would actually, because of this division sign, the way it's written, you would actually do this 4 divided by 2 first. And then you would go ahead and figure out those other subtractions. Okay. However, there's something inherently different about this one. Okay. This one over here, and I think math teachers haven't always made this real obvious to students, but when you have a division sign that goes straight across like this, okay, there's something inherently different about that division sign versus this division sign. With this division sign, you're supposed to realize that you have parentheses in both the numerator and the denominator. And so remember, with the order of operations, you always do parentheses first. And so some students were breaking the order of operations, but because they don't see the parenthesis sign, but you're supposed to assume that parenthesis signs are there. Whoever decided not to write the parenthesis sign, I don't know, but we don't write the parenthesis sign. But what we're supposed to do is we're supposed to go ahead and calculate everything in the numerator, parentheses, calculate everything in the denominator, parentheses, and then what do you do in the end? You take those two numbers and divide them. All right. So that's the difference between these two. Okay, is that with the second one, you're supposed to assume that you have parenthesis sign in the numerator and the denominator, and this has everything to do with the formula with regards to standard deviation. And actually, you saw this with regards to the mean. Remember, the mean had the summation of x divided by n. Well, you actually had to sum all those x's first. All right, so you actually had to do some addition first, and the reason why you were able to do the addition first before you did the division is because you had a line that went straight across like this. Okay. So our answer actually turns out to be 4, because you would do the 8 minus 4 first, which is 4, 2 minus 1, 1, and then you go ahead and divide, and you get 4, right? By the way, you would not get 4 for this up here, okay? So just wanted to point that out to you before we got to the formula. So, here's a review of the order of operations then. What do we do first? We always do parentheses first. 2, you do exponents. Do you remember what's next? Multiplication. multiplication, then what? Division, then addition, then subtraction. Okay. So one of the major reasons why you learned the order of operations was actually, believe it or not, so you can read a formula, okay, and work with the formula. That's one of the major reasons why you learned the order of operations. So let's take a look at the formula for the standard deviation. So there's the formula. Now don't freak out over it. We can work with this, okay? And I just told you that don't look at this as a bunch of jumbled mess, because it's not. Okay, it's very much organized. You just got to follow the order of operations. Excuse me. So let's do this. Let's take a look at all the different components of the standard deviation formula to make sure that you understand them all. Okay. So first, you have the summation sign, right? Here's a summation sign. What does that mean? It tells us to sum something. Now, remember, it's not always about summing x. All right. It just means to sum something. X. Okay. So now, remember, we have a summation sign in our formula. What does that mean about x? There's multiple x's that you have to do something with. Okay, remember we talked about that in the last section. X is not just one number. Okay, like in an algebra problem. When you have a summation sign, that means you have multiple x's and you got to do multiple things with them. So x stands for all the values of the variable here. X bar, we talked about, that is the sample mean. So there's x bar. And n, the sample size. Alright? So let's break this down into little pieces parts. What do you always do first with the order of operations? You always do what's what? In parentheses. And since we have a summation sign, that means we have multiple values of x's. Okay? So what is it telling us to do? Take each one of the x's and subtract off the sample mean, x bar. And you just keep on doing that. You go to the first x, subtract off x bar. You go to the second x, subtract off x bar. And you do that for all the x's. Okay? What we call that is calculating the deviations. So anytime you take x minus x bar and you do that for all the values of your data set, you're calculating the deviations. Then what's next? The order of operations. You would go ahead and square things. So since this is in parentheses and the square is for the parentheses, you would take all the values of your deviations and square them. Now, since we have a division sign here that goes straight across, what do you have to do? You have to do everything that's in the numerator, you got to do everything that's in the denominator, and you would divide those two. So what you got to think of is that there's parentheses here, and there's parentheses down here. So you would go ahead and take the squared deviations and do what with them? You would add them. That would go ahead and tell you what the entire numerator is. Okay? The denominator, so we got the numerator. The denominator is simple. It's n minus 1. Sample size minus 1. And then after you do that, what are you going to do? You're going to take those two numbers and divide them. So, and then the final thing is, since this square root sign is over the whole thing, it's not just over the numerator, it's over the whole thing. Alright, after you do the division sign, you would go ahead and figure out the square root of that calculation. Alright, so there's the steps, and let's walk through this, alright, for our two data sets. So there's data set A and data set B. There's our standard deviation formula. So what we're going to do is we're going to calculate the standard deviation of data set A first. Okay, so we'll get rid of B. There's A. All right. So the very first thing that we're going to have to do is that if you don't have the value of x bar, you need to calculate it. All right. So if nobody's given you the sample mean, go ahead and calculate it. So there's the calculation. All right. We have x bar is equal to summation of x divided by n. So the summation of x is 100. So you would add those up. We get 0 plus 10 plus 20 plus 30 plus 40 That's 100. We have an n of 1, 2, 3, 4, 5, and so we have an x bar of 20. Okay? Okay. So, I think we're ready to actually get into calculating the standard deviation now. All right? So I'm going to set up these you're going to see a couple of columns set up, and all these columns is that it's following the order of operations. What does the order of operations tell us to do? It tells us to take each one of our x's and subtract off x bar. So I've set a column like that. Okay, so we're going to look at this first number. The first number is 0. We're going to take 0, and what are we going to do? We're going to subtract off 20, x bar. But we're not going to stop there. Okay, we got to do that for each one of the x's. Where's the next x? Right here. It's at 10. We're going to take 10 minus 20, we get a negative 10. And we just keep on doing that. So what's the next one? 20 minus 20, because we have 20 for x, we have 20 for x bar, we get 0. Keep going. 30 minus 20, that's a positive 10. And finally we get 40 minus 20, we get a positive 20. Okay? Every once in a while in statistics, you get to check your work, and this is one of the places that you can actually check your work. All right, this column right here, the sum of these deviations always has to equal 0. This always has to be the case. This always has to be 0. If it's not 0, you've done something incorrectly. Either you calculated x bar incorrectly, or you did one or several of the deviations incorrectly. Okay, but that column has to sum to 0. If it does, you are on the right track, my friend. Okay? So we have our deviations. What's next in the order of operations? We got to take our deviations and do what with them? We have to square them. So I made another column. Now I have the deviations squared. Well, the good thing is that here are all the deviations. Okay? So we just got to take this number and do what with it? Square it. So you get 400. So now, if there's ever a place that students make a mistake, it's right here. They forget to take away the negative sign. You got a negative number squared. You're going to get a positive number. Okay? So you get 400 here. Then what are we going to do? We're going to take a negative 10, square that. What do you get? 100. Positive 100, right? You do that for each one of these. So we got 0 squared. That's 0. Then we have what? 10 squared. That's 100. And when we got 20 squared, that's 400. All right? You've done the hard part. If you can get to that point, you've done the hard part of calculating the standard deviation. Okay? Why? Well, the rest of it's pretty easy. So you just did the squared deviations. What's the last step for the numerator? You got to take those squared deviations and sum them. And so the sum turns out to be 1,000, and that's the numerator. So the numerator up here would be simply 1,000. All right. So we have to do the denominator now. And here is 1, 2, 3, 4, 5. That's our sample size. 5 minus 1 is 4. Okay, so there's our denominator. And minus 1, we got a 4. Okay. So looks like we have the square root of 1,000 for the numerator divided by 4. If you put that in your calculator, you can do that in your head. That turns out to be 250. Okay. And when we hit the square root button, it should come out to, let me do that in my calculator just to make sure that I did that correctly. Yep, comes out to 15.811. So I rounded properly to the second decimal place. If Web of Science says take it out to 3 or 4 decimal places, fine. Round properly, okay? But here I'll just take it out to 2 decimal places. That's plenty, okay? By the way, 15.81 what? Well, the standard deviation gets the same units as x, okay? And so, remember, x was in terms of minutes? Well, so we would say then for this problem is that the standard deviation for this data set would be 15.81 minutes. Same units of x, all right? So there was the standard deviation for A. we'll do the standard deviation for data set B, and we expect B to be smaller than that because we said B was more condensed. Okay, so let's see. So let's go ahead and calculate the standard deviation for data set B. Here's the two data sets again. We'll isolate B. All right, and what do we got to do first? We always have to calculate what? We have to calculate X bar, right? If you don't have it, got to calculate it. All right. So I got here. Maybe you should do this in your calculator. Maybe you should pause this, make sure you can do this in your calculator, or do this in your head or whatever, or however you want to do this. But we would take 6 plus 8 plus 10, 10, 12, 14, add them all up, right? You get 60 for the numerator. What's n? 1, 2, 3, 4, 5, 6. So we got 60 divided by 6, or 10. There's our X bar. By the way, if X bar happened to turn out to be 10.2, unfortunately you can't use 10 for X bar to calculate the standard deviation. You would actually have to use 10.2. Here, it turned out to be exactly 10. So that's good. We have to work with a bunch of crazy decimals for the most part. All right, so we have an X bar of 10. So the very first thing, we're going to set up our first column as X minus X bar. We're going to calculate the deviations. So we have 6 minus 10, that's a negative 4. You go to the next one. 8 minus 10. What is 8 minus 10? Negative 2. All right? And you go to the next one. And actually I did both of these at the same time. Because why? They're 0, right? They're both 0. And then what do we have? We have 12 minus 10, that's 2. 14 minus 10, it's 4. Remember what I told you, that this sum always has to be? This sum always has to be 0. And is it? Yep. Check mark, right? We're on the right path. Okay. Now that's not saying that the deviation is 0. You got to continue on. That's just telling us that we've done all the calculations correctly, probably. All right. What's the next step in the order of operations? You've done it. What's in parentheses? The innermost parentheses. Now we have to do the exponent. So we have to square these guys. So you're going to take the negative 4 here and square it. You get positive 16. Then you go to the next one. Negative 2, square it. You get 4. 0 squared, 0. 2 squared, 4. 4 squared, 16. And remember, you're going to have basically, you got to think of this as parentheses in the numerator. You got to think of parentheses in the denominator. So what is it telling us to do? We've got to take those square deviations and add them, sum them up. I got here 40. So that means 40 is in the numerator of our calculation. But now we have to do the denominator, right? So let's see, the denominator is n minus 1. Here, n, remember what n was. N is 6. So we have 40 divided by 6 minus 1. Okay, so we got 40 divided by 5. That's the square root of 8. Okay, and so I got here 2. Let's see, let's just make sure. I'm going to put this in my calculator again, just to make sure that I did it correctly. Looks like I did. So I got 2.828. So I'm going to round it to 2 decimal places properly. Again, if StatCrunch tells you 3 decimal places, fine, or 4, whatever. Excuse me, WebAssign, that's fine. But here I'm just going to round it to 2 decimal places. So I got 2.83, and again, it's minutes. And what did we find out? That data set B, because the standard deviation is smaller than data set A, it looks like it's more condensed. Okay, data set B is. All right, here's our standard deviation again, and how about you work on this one? So why don't you pause the video, okay, and see if you can work out standard deviation, okay? Maybe after you calculate the deviations, you can see what my deviations were, and then you can calculate the square deviations, see what mine were, and see if we get the same answer, okay? So why don't you get a piece of paper and work this out. All right, so let's see here. Hopefully you got your piece of paper. The very first thing I think we're going to have to do is going to do this on the bottom, keep this away from everything. We got to calculate x bar, don't we? Okay, and so it's a summation of x divided by n. So we got to add these guys up. So 20, 30, we got 36 it looks like. 36 for a sum. Okay, and what's n? N is 1, 2, 3, 4, 5, 6. That means, looks like x bar is 6. Okay. Alright, let's calculate our deviations. X minus x bar. Remember, when you have a summation sign in a formula, that's telling us that we have multiple values of x. Okay, here are all the x's, and so we got to, this is, x is not just one value here, it's all the values of x. Okay, so here's our first x, we got 4. We'll subtract off 6. And what do we get? We get a negative 2. Bear with me, because it's slow in writing this. So we got 0 minus 6. What do we get? Negative 6. We got 10 minus 6. We get positive 4. 13 minus 6. We get 7. We got 7 minus 6. That's 1. 2 minus 6. That is a negative 4, looks like. Okay. Alright, so what did I tell you that you should do? You should take those values and add them up. Alright, so I'm going to get my eraser here. I'm going to erase some of this stuff right here. Alright, there we go. Get rid of that. Get my pen back out. X bar was equal to 6. Alright, so let's sum this up. So what do we get here? We get, let's see the negatives. We'll group the negatives together. So the negatives, we got negative 6, negative 4, that's negative 10, negative 12. Okay, and so if it's going to sum to 0, that means we should get the positive numbers to be a positive 12. Let's see, 4 plus 7, that's 11, plus 1, that's 12. Looks like when you add that stuff up, what do we get? We get 0. Now, if you didn't follow what I just did there, that's fine. Just put them in your calculator and see if you get 0. If we got 0, that means we are on the right track. Okay, what's the next step? We got to take those deviations and square them. So we got x minus x bar. We'll go ahead and put that in parentheses and we'll square them. I'm not going to write all these out. So we got a negative 2 squared. What is that? 4, positive 4. Negative 6 squared. What is that? 36. 4 squared is 16. 49. This next one, we got 1. 1 squared is 1, and the negative 4 squared is 16. Okay? So go ahead and put those in your calculator. That is supposed to be a 49. There we go. Okay? So what do we got here? We got 4 plus 36 plus 16, 49, 1, and 16. When I add that up, I got 122. So that is the summation of all the x minus x bar squared. Okay. We have our numerator. Okay, so we have the square root, and then we have 122 for the numerator. What's the denominator? Let's see. Denominator is n minus 1, and so we had 6 minus 1. So we got to put it in our calculator. So remember, you have to think of that as parentheses there. So that's 5, right? So we got 122 divided by 5. I'm not going to rewrite that one again. That's going to take too long. So I'm just going to put in my calculator 122 and divide that by 5. I should probably be able to do that, all this stuff in my head, but it's early in the morning. It's only like, it's actually 4:30 in the morning right now. I just didn't feel like doing that calculation. So we got 24.4, and remember, don't forget to take the square root of that. Okay, so let's see, we got a square root, 24.4. What do we get here? I got here 4.939. So I got here 4.939. And so you know what I'm going to do? I'm going to round that to 2 decimal places, 4.94. Since this number is 5 or greater, we'll just round it up. Okay, and technically, whatever x was supposed to be in terms of, I didn't define x, did I? But let's say x was in terms of, I don't know, how about pounds? Okay, we could then say that this is the standard deviation for this data set would be 4.94 pounds. Okay. All right, so there's the calculations to the standard deviation. Okay, hopefully you got what I got. Let's do this. Let's give you some. I got to give you some tidbits with regards to standard deviation. Okay, so just like the mean. Okay. By the way, if this video is getting too long for you and you need a break, take a break and come on back. Okay, but I'm going to continue on talking about the standard deviation. So there's 2 standard deviations that we're going to deal with in this course, just like the mean. There's the sample standard deviation, which is a statistic. Why? Because it's a standard deviation that's coming from a sample. And the symbol that we go ahead and use for the sample standard deviation is S. So that's the formula that you'll see on the test with regards to the standard deviation. You'll say S is equal to, and there you go. Okay. So S, the sample standard deviation. Please know that. Just like x bar is a sample mean, you need to know that S is the sample standard deviation. 2, we have the population standard deviation. That's a parameter. Remember, we usually use Greek letters here. There's one exception in this class, but for the most part we use Greek letters to represent the parameters. And so this guy right here, this funny looking O with this, this top to it, this is actually a lowercase sigma sign. And so if you're talking statistics with someone, or someone's talking statistics with you, and they talk about sigma, they are probably not talking about the summation sign. They're actually probably talking about the lowercase sigma, and they're talking about the population standard deviation. All right, so that's the next thing that you have to learn, is that you have to memorize that lowercase sigma, okay, is the population standard deviation. Okay. All right, what else? Some final thoughts about the standard deviation then. 1, it is never negative. It's never negative. If you get a negative, it would be impossible to get a negative because we have a square root there, and you can't, you'd be working with imaginary numbers if you try to take the square root of a negative number. Okay, and standard deviation is not an imaginary number. Okay, and so it's never negative. If I didn't say that it couldn't be 0, okay, it can be 0, that would be a special situation. What can you think of the situation where the standard deviation, now remember what we're measuring. We're measuring the spread of the data set. We're saying there's, if a data set had a standard deviation of 0, that means there's no spread to the data. So what does that mean then? That would mean that all the values of the data set are exactly what? The same. So for example, if your X had just a bunch of 7s in it, and that's all it had, 7, 7, 7, 7, 7, 7, 7, 7, 7. Well, standard deviation is not 7. Okay, so this would not produce a standard deviation of 7. The standard deviation in this case would be 0. There's no deviation from the mean from any of your observations. Three, I've already said this, that its units are the same as X. And what we find out is that, remember, the mean has exactly the same units of x, and so the mean and the standard deviation have exactly the same units. They have exactly the same units of x. And what we find out in the next, in part 2 of section 2.4 is that the mean and the standard deviation, they play nicely together. And I'll show you that in the next video. All right. The last thing that I want to talk about is I want to visually show you what's going on with the standard deviation. All right. So here's data set A, here's data set B. So I've made dot plots for both of them. Okay. Now remember, the mean for data set A is at 20. Okay. And so what we're doing is we're measuring back how far each of these observations are from the center. Now, there's no deviation for this one because that observation is exactly equal to the mean. But we're measuring how far each of these observations are from the center. Okay, so notice how much of a distance there is. Okay, and over here, notice the distance is here. It's a pretty small distance. Small distance, small distance, small distance, and then we had two observations that had no distance between, because that was the mean of data set B. Okay, so that's basically what we're doing. All right, is that we're measuring how far away each of the observations is from the mean. All right, and why do we have to square those? Why do we have to do all those squaring? The reason why we have to do the squaring is because, remember, I told you when you summed up all the deviations, what did they always add up to? They always add up to 0 for every single data set. All right, well, that's kind of useless. Okay, and so we wanted to somehow utilize these distances. It's just that we had to get rid of the compensating positive and negatives. Okay, so how do you get rid of negatives? Well, there's a couple of different ways, but we decided in statistics to go ahead and square all those. Okay, to square all those to get rid of the negatives. Okay, that's why we square the deviations. All right, so we get rid of these compensating negatives and positives. All right, so visually that's what's going on with the, graphically that's what's going on with the standard deviation. All right, I think we're to the end of the video. Thank you for your time.